Well, when we hear about earthquakes striking in California, we often point to the San Andreas Fault. But did you know California actually has two pretty active faults?
There hasn't been a big earthquake along the San Andreas Fault for years. Scientists now believe that an earthquake near the fault line's epicenter could be more devastating than previously thought. Thomas Jordan, the director of the Southern California Earthquake Center, recently said something that would have sent shivers down the spines of every Californian. The San Andreas Fault seems to be in a critical state and could cause a big earthquake soon. Californians are already aware of the risk of earthquakes, but the warning that the southern part of the fault looks like it's locked, loaded, and ready to go is something new. Why is this famous seismologist making these scary statements? Well, the fact is that the southern part of the San Andreas Fault system hasn't had a big release of stress since 1857. In simple terms, the San Andreas is one of many fault lines that roughly mark the boundary between the Pacific and North American tectonic plates. Both plates are moving toward north, but the Pacific plate is moving faster than the North American plate. This means that stresses are always building up between the two plates. In 1906, a 7.8 magnitude earthquake in the San Francisco Bay Area released some of these stresses in a very bad way. In 1989, the 6.9 magnitude Loma Prieta earthquake in Northern California did the same thing. But events of this size haven't happened along the San Andreas Fault in the southern part of the state. The 1994 Northridge earthquake was caused by a nearby but separate fault system. This suggests that one is coming soon, and given how much stress might have built up, it will be the big one when it does. Earth scientists have been collecting information at key paleoseismic sites along parts of the San Andreas Fault in order to figure out when earthquakes happened there in the past. The numbers show that in many places along the San Andreas Fault, we're past the average time between big earthquakes. People often say that we are overdue because we have gone above the average, but it's not that simple. First, let's zoom out and look at the big picture. San Andreas Fault Zone, the big picture. Scientists have a good overall picture of the San Andreas Fault Zone. About 28 to 30 million years ago, the SAFZ began to move. Since then, it has slipped horizontally, called transform motion, a total of about 300 to 350 kilometers. The Pacific tectonic plate is on the west and the North American plate is on the east. The SAFZ is the main part of the boundary between the two plates. The zone component of the name refers to a system that includes a major fault and numerous subparallel faults that work together to create motion between the two plates. In Northern California, the zone includes the Hayward, Calaveras, Northern San Andreas, and other faults. In Southern California, the zone is even bigger and includes the Southern San Andreas, the San Jacinto, and other faults in the Los Angeles area. The distance between these two tectonic plates moves 50 millimeters per year, which is about 2 inches per year. However, this rate is spread out over all the faults that make up the SAFZ. Each block is always moving, which we can see by looking at GPS data. The faults are the lines between the blocks. However, the edges of the blocks are stuck and only move when there are big earthquakes. Some faults creep a little bit, but most are locked. An earthquake happens when the stress from the moving plate is stronger than the friction that keeps the edges of the plate from sticking together at the fault. The part that was stuck moves, and each block's edge catches up with the rest of the plate. The plate is always moving slowly, but the edges move at different times. Many of the places paleoseismologists have been looking at are along key parts of the SAFZ, where there are lots of people or big buildings that would be damaged by a big earthquake in the future. Let's start in Southern California and work our way north. Southern California. Let's take a look at the map of faults in Southern California. Paleoseismic sites were used to figure out the average time between big earthquakes, triangles. The size of historical breaks is shown by thick red lines. The last big earthquake on the San Andreas Fault in Southern California happened in 1857, and the one before that happened in 1812. Since it's been about 160 years since the last earthquake and about 45 years since the last historic one, it's clear that the fault doesn't work like a clock with a regular beat. History doesn't give us enough information to know if there's a pattern to when the earthquakes happen, but paleoseismology has given us a lot of information. Along the southernmost part of the San Andreas, from Palm Springs to the Salton Sea, earthquakes happen every 200 to 300 years on average. About 300 years ago, when the Spanish were exploring the area, there was the last earthquake, but there's no record of it. Instead, radiocarbon dating tells us how long ago the most recent earthquake and 6 others that have happened since 800 AD. Several scientists have looked at a paleoseismology site in Wrightwood, California. In 2010, the detailed data from all of these studies were put together to make a single timeline. The 3,000-year record includes 29 earthquakes that broke the surface. Careful analysis of the age of the earthquakes, including the uncertainty of radiocarbon dating, showed that the average time between earthquakes is about 100 years. A mathematical analysis shows that the times between earthquakes at Wrightwood are more regular than clustered. Only 4 times in the past has the time between 2 major earthquakes been longer than the time between the last 2 since 1857. The results of this study show that a big earthquake is likely to happen on this part of the San Andreas Fault in the near future. Along the fault, another site called Fraser Mountain has been looked into. It's about 100 kilometers to the northwest. At that spot, the record goes back about 1,000 years, and the sediments show that there were about 9 big earthquakes, including the one in 1857. Scientists are trying to figure out how big earthquakes happen by comparing data from places like Wrightwood and Fraser Mountain. They ask questions like, how typical was the big magnitude 7.9 earthquake in 1857? Or, are quakes like the one in 1812, about magnitude 7.1, more common? Because the magnitude scale is a log scale, there's about a 25-fold difference in how much energy these different earthquakes release. Northern California. The Hayward Fault in the San Francisco Bay Area goes through a very populated area, so it has been studied a lot. The last big earthquake on this fault happened in 1868 and was about magnitude 6.9 in size. Since the 1970s, the fault has moved about 4.6 millimeters a year, or 0.2 inches a year, which is only half of the long-term slip rate. This means that stress is building up on this fault. In 2007, a paleoseismic study was done at Tyson's Lagoon, which is now a BART station. The study found evidence of 12 paleo-earthquakes, including the one that happened in 1868, with an average time of 160 years between each one. The average time between the 5 most recent earthquakes is about 140 years, which is less than what it used to be. The study found that a surface rupturing earthquake is 33% likely to happen in the next 30 years. The Hayward-Rogers Creek Fault system in Northern California goes north to become the Macama Fault. In 2014, a paleoseismology site at Hale Creek on the Macama Fault showed the same results as the Hayward Fault to the south. The fault is moving slowly and has large earthquakes every so often. A large earthquake is expected to happen soon. In 2013, a hole was dug at the Hazel Dell site near Corralitos, California, to learn more about the section of the San Andreas Fault in the Santa Cruz Mountains. The famous 1906 San Francisco earthquake was the last time the Santa Cruz section was broken. It is 62 kilometers or 39 miles long and goes from Los Gatos near San Jose to San Juan Bautista, California. Observations in the trenches, radiocarbon dating of charcoal, wood chips, and small plant remains, and a reevaluation of 3 paleoseismic sites that had been studied before and were close by, all showed that earthquake activity changed in the past. Between 1838 and 1906, there were 3 earthquakes, but there had been none for the 500 years before that, and there have been none in the 110 years since 1906. This shows that there are some short times between earthquakes and some long times between earthquakes. New studies along the peninsula section of the San Andreas Fault, which is farther to the northwest, also show that there was a long time between the 1906 earthquake and the one before it, which happened around the year 1300. Before 1300, the time between them is about 200 years. The part of the San Andreas Fault called the North Coast is north of San Francisco. Studies of this part of the fault show that the average time between earthquakes is between 200 and 300 years. Now what? Paleoseismic data from different parts of the San Andreas Fault zone all show that some parts seem to be past due for a big earthquake, or past the average for an earthquake. But we can't use the data to make predictions because we don't know enough about earthquakes to know where the next one will happen, how big it will be, or when it will happen. Let's pretend for a moment that we know exactly where, when, and how big an earthquake will be. You might think that would be good, since you could leave the area before the earthquake and then come back after it. But if you only try to avoid earthquakes, you won't be able to fix most of the problems caused by the shaking. As you went back to your house, you would probably see buildings and bridges that were damaged or had fallen down, broken pipes and power lines, and the burned remains of fires. When you walked into your house, you would trip over overturned bookcases, broken glass from mirrors that were no longer on the walls, and piles of kitchen cabinet contents. We do know that California is earthquake country, so we need to be ready. In particular, we need to make sure that buildings and infrastructure can handle the shaking from an earthquake or are easy to fix. Scientists are working to improve their predictions of how often and how much the ground will shake during future earthquakes. This will help engineers and planners know where to focus their efforts to reduce the damage caused by earthquakes. Using the forecasts, we can build structures correctly, plan for how to respond to an earthquake, and be ready at home. This can make a big difference in how bad a big earthquake is. Predicting devastation. In order to try to figure out what would happen in a big southern San Andreas earthquake, the U.S. Geological Survey made a model of a 7.8 magnitude event with slippage of 2 to 7 meters to represent the stresses that have built up in the area since the last big event. Based on this model, it was found that the most damage would happen to structures that were in the middle of the fault. Since the Alquist-Priolo Earthquake Fault Zoning Act was passed in 1972, there haven't been many buildings like this one. The 966 roads, 90 fiber optic cables, 39 gas pipes, and 141 power lines that cross the fault zone would be hurt by this slippage. Damage due to buildings was estimated to cost a total of $33 billion, with newer buildings being less likely to be hurt than older ones. As gas mains and water pipes broke, fires would start, just like they did after the Northridge earthquake. In fact, the damage from the fires is thought to be more expensive than the damage from the initial shaking. It is thought that 1,800 people have died in total. And just when it seems like things can't get any worse, the main event will have upset the region's tectonics so much that a series of aftershocks that could be very strong will start. In 2011, Christchurch, New Zealand, was hit by an earthquake with a magnitude of 6.2. Since then, the city and the area around it have felt more than 10,000 aftershocks. Luckily, the movie San Andreas is all made up. It has the same level of exaggeration that we've come to expect from Southern California-based filmmakers. Still, it is very likely that the San Andreas will cause a big earthquake in the not-too-distant future. When it gets there, it will do a lot of damage, and Southern California will be hit hard. But Californians are used to these things, and the state's infrastructure has been built with earthquake safety in mind in recent years. Don't worry about tsunamis or deep chasms opening up, but do expect the ground to shake violently, buildings to be damaged, fires to start, and the economy to be affected in a wide range of ways, as the area could be shut down for a long time. That pretty much wraps this video up, guys. Thanks for watching. So, what are your thoughts about these grim predictions related to the San Andreas Fault? Share with us in the comments below. Make sure you subscribe to this channel with a bell notification if you enjoy watching our content. We upload some awesome stuff here, which you will most certainly enjoy. Hit a like on this video and leave a comment below. See you guys in the next one.